So this is a kind of an ad hoc structural modeling video conference where we're going to be working with Mary and Peter to detail the steps that a person would go through to download the BSMP material from GitHub, unzip that material from GitHub, talk about what's there, and then talk about the resources, the charts that are available there, the documents that are available there, and also the software and how they relate to each other. So this kind of recording is kind of a way for people to understand how to get the material from GitHub, and then once we get it downloaded and working, then we'll walk through that a little bit. So the first thing to do, this particular page, is when you click on the GitHub link, which shows on my screen, but it does not show on your screen. There's a drop-down box. Again, it says open the link in a new window. So it's important that you really want to, when you go to GitHub, you really want to open that in a new window. So I'm going to click on open in a new window. And I have a new window opening, but I'm going to have to, due to the Google Hangouts here, I'm going to have to share that, reshare that. So stop sharing here and go to this application. Now I'll share the GitHub window. Okay. And so now we're at the GitHub window, and this is for the basic structural modeling project, which is on GitHub. As you notice, put up there about 3 years ago. We have a README here, so let's look at the README on this particular part, so just home of the basic structural modeling project. This was one of our first repositories that we put out. And it basically we have a number of problem definition documents. We have a problem definition document, a conceptual solution report, and then a detailed design report that's included. Also included in this package of information is a Sage Math set of examples that basically show how to address the fundamental mathematics that was developed by Warfield using the Sage Math tool from the University of Washington. We have a number of tests here that lists. We have the tests that basically we use to test the web applications, and then there's the basic web application, which addresses the north of city problem. So this is kind of the most fundamental package of information about dealing with this type of structural modeling. So what we'll do now is, once you get to this page, as part of the page, you go over to clone or download. And then when you get to the, what you want to do there is to basically download the zip file. So click on this one, download the zip file, and it will take a while. It's a fairly, I forget exactly how many megs, but there's a lot of information in there. There's a lot of slides, there's a lot of documentation. So it just takes some time to download.
Joe, I don't know if you can do something, but for some reason I'm not getting the whole screen on the picture, although I can click on the black, click where it is, and it comes up. Oh, that's better. I don't know what you did, but something happened.
Okay, that's all right.
Thank you.
Okay. So let's see. Let me see if I can recover from that. I didn't share the screen. Hopefully it will have been recorded, but essentially what happens, while this is downloading here, we have, you click on the clone or download, and you do download zip, and then the zip file will download. And this particular archive has documents in it, so we have our problem definition report, conceptual solution report, and our detailed design report are in here. Of the Sage Math tools and the Sage Math code that basically walks through the fundamental mathematics are presented by Warfield in the Societal Systems book and also in the Mathematics of Structure book. And we have some tests that test the web apps. And of course, we have the web apps that we will be walking through here. So as you can see, this is still downloading. We're up to about 27 megs right now. So it's not a small file. And it has a tremendous amount of information in it. And all of the information in this particular archive addresses the 19 cities problem, where we just look at which city is north of another city. And the problem itself is fairly straightforward. We know we have 19 cities, and we know we want to order them of which city is north of the other city, but we know that in a global sense. But we really have no information about the individual cities, how they relate to each other. And so in this example, what we'll do is we go through and order the cities using the structural modeling techniques. So now this master file is downloading. And once you download that file, then you will need to open it. So let's have it here. If you can see it on my, I think you can see it on the screen right here.
Yes, I can see it.
Okay, then you click on that. This is, I'm using a Mac, so different machines might have a different approach. Then you have the folder, then the folder comes up. Then you need to open the folder. Within the folder, you have the documents, the license, the README, the Sage Math, the tests, and the web apps. So we will just kind of go through these a little bit. So this is the basic structural modeling conceptual solution report. This is the appendix for that report right here. Then this is the report. And then we have the detailed design document, and then we have the problem definition document. So we've just basically written documents that kind of describe what the problem is and how we plan on addressing it. The Sage Math tool. Our Sage Math tool works with spreadsheets. And we have worksheets basically. So we have these 4 worksheets that address the different types of mathematics and the functions that we put together to execute Warfield's augmented Boolean algebra and also structured mathematics. There was a number of unique things that he injects into the mathematics. In many cases, if you're not really aware that he made these changes and you use standard type of functional definitions, then you have errors and it creates a lot of problems. So these spreadsheets are used to emphasize that and what the specific mathematics are. And of course, this is the test. We wrote an automated test to load random. So basically we did create a random generator to generate random series of cities to test the software. And these are test scripts for our web applications. And then of course, then down here we have the web application itself and the process screenshots. So the web application itself is here, and the process screenshots are in here, north of structure. Now the process screenshots are also packaged as an HTML type of JavaScript package. So you just need to click on that and open it with a web browser. Pull up a web browser. And then it brings up the examples. So here, within the screenshots, what we've done is that it's a structure system using the Northrop relationships, and what we'll go through step by step with screenshots and talk about what you need to do with the software. So on this particular case, let's see. Let's go and just walk through this a little bit. So there's just this slide deck overview, and it basically talks about what we're doing with a mix of the logical inference and the empirical data collection. And they're integrated. This is just a screenshot of the initial screen of the software, what you have. And then this is what happens when you initialize the city grid. And in this particular case, it should point out that we're doing one city at each level. Where we're restraining this, we're only allowing one city at each latitude. We have a different approach where we have multiple cities, or you can do it in a different way, which we can talk about later on if there's some interest in that. Then we go through and we just simply start picking two cities to find out which city is north of the other city. So here's what we said is city 4 north of city 11, right? So we go down here, we say 1 on the column level. We go over to 4 is city 4 north of city 11, right? Row 11. And then we say yes. And so, okay, there's a green 1 placed there because that's empirical information that we have. We know as a matter of fact that that's true. And due to the nature of the relationship, then we know it from empirical information that it's false, that city 11 is north of city 4. So essentially, this activity addresses the relationship between city 4 and city 11. But what we know globally about the structure that will come out of the present of this work is that the north of will have a hierarchy that fills all of the bottom lower triangular of this matrix should be 1s. You should have no 1s in the upper triangular. So this is a global type of evaluation of the structure that we use so that to get the proper configuration for the matrix. So when the matrix is in the proper configuration, all 0s are in the upper triangular, all 1s are in the lower. Okay. Now here's a case where we say, well, this city 17 is north of city 5. So we go over here, walk along, city 17 is north of city 5. See, now we have a green 1 in the upper triangular. So that's really not the proper configuration. All the 1s are supposed to be in the lower configuration. And when we look over here in this part of the screen, we say, oh, green is in the lower section or green is in the upper section. In this particular case, green is in the upper section, so we press the green is in the upper section button. And what happens there is the computer program will swap these columns. See now that 17 and 5 have been swapped. 17 and 5, so that now we have 5 and 17, and 1 is in the proper configuration. And we move on and go, is 4 north of 15, and so on. We continue in that mode. Going through, gathering information. And in this particular case, we just now inferred a point, this blue 1 down here. And this is the process by which you leverage the information that you already have gathered, this empirical information, and you do that by inference. Now in this early software piece, our strategy was to, well, just randomly select cities, because no one city pair is any, it's any higher probability of being north of each other than any other. So it's just equal probability, so just randomly select them. Since then, we've taken more of a structured approach, and actually don't do these random ones at first. We start at the top and start working our way down. And we're collecting data on which is more efficient, but just to point out that this is an early piece of work that we did about 3 years ago, and these random cities that we select to get started with at first, more or less now we just start at the top and start working down. So then you keep going through, asking the questions, doing the inference, swapping the rows and columns, and then you continue until you make the order. And as you notice in this chart, you have the heading on the chart is the question, is 5 north of 12. You have the information that goes in here. So this really is a step-by-step analysis and details of basically what we're doing. And so as you can see, as we walk through here, you add more and more. And an interesting thing to note is the more detailed empirical information you get, the higher probability for inference. And we did a paper on that and showed the relationship between the number of empirical data points and the number of inferred data points. And the inferred data points really take off quite rapidly after you get a certain place or a certain percentage of filling of the matrix. So again, this particular set of charts, it shows every step in going through the software, which we did about 3 years ago, which was our first cut at this. So is that helpful, Peter?
Yeah, absolutely. I think you've actually walked through that on some of those videos, but it's good to see that you can do that on the slides. And I think somewhere in my distant past, there's a mathematical formula, isn't there, to when the inferences would be, when you would get to a certain number of pairs, that the inferences would complete?
Right, there's a couple of there's a couple ways of looking at that, and one of the things that we're looking at here in this specific example is we're actually ordering the cities. And if you notice, we had automated software tests, and so the software knows in advance what the proper order is. And so what we found in our first versions of this is that the software then didn't go through and complete all the way, because they reached what they knew was the proper configuration. That wouldn't really happen when you're working with people and groups and are really discovering true unknowns. And so that's kind of an artifact of our testing and approach to this. But yeah, so there's really it's really quite interesting to see how that works. But anyway, so this are the charts. So you can go through, and the process is complete, system structured. As you can see, there's about I think 2 or 3 more questions that should have been asked, but the computer knows that, oh, okay, I've already hit the right configuration, so it just said we're done. Right. So it's kind of how that worked. All right, so now let's go back and see where we were with this. We were in the We were on
in the zip folder. Yeah.
Yeah, in the zip folder, we were over here. We just walked through the screenshots. So now we'll bring up the, we'll open this. Let's go with Google Chrome. Okay. And so then Google Chrome is up. This should be familiar from the process charts we just went through. And so you just basically click initialize the city grid, initializes the grid. You start entering information and going through the process.
Oh, really? Okay, that's pretty straightforward. So it just literally the JavaScript is embedded in the web page when you click on the web page, and that just runs, then, does it?
Right. So one of the design goals for this for these initial web pages are to have serverless web pages, single page applications that will simply run in any browser to make it accessible to the most people as possible. So what happens there, because we've kind of ignored the networking component where you'd have a bunch of people that would be putting data and keeping track of state on a server. And as I said, they did this 3 years ago. Now that's kind of where we're headed with our next architecture, is to I'll probably use Juniper notebooks to do that, because all of the plumbing and networking and keeping track of all the people working together on a document or in a certain part of it, that's all provided and done by the Juniper software, and we just need to make an interface to it.
Interesting. Okay.
And then so this here, basically if you go to this part there, our documents, contact information, about, I think this goes there, go back to the web page. So there's, basically that's what it's all about. So if there's any other specific information I can provide.
Well, that's good on explaining the city problem, and I suppose what I'm interested then is where you are in the project at this point in moving to where you would have the opportunity to enter other information, and how the number of rows and columns is calculated for a particular set of statements that you might wish to structure.
Yeah, that's really a good set of questions. We have a very specific relationship here north of, which is transitive, asymmetric, and irreflexive.
Right, exactly. I mean, it's set in geography, really, right?
Right.
And as you said, and there's nothing at the same level which would create another issue, which I'm sure you would address in some other occasion. But
well, there's two ways. There's two ways to address multiple cities at the same level. First way is just go through and do a clustering event first, where you would all the cities at the same level. You would just cluster those into equivalency classes, and then you would do another one to order those equivalency classes. Or you could do them at the same time. And so we've done one where we have more than one city at the same level, and we collapse those essentially, and just do that as we get the information. So the idea there is that if you have a situation that's truly unknown, you really don't know if there are any cities that are at the same level. And if you run through and do a clustering thing, then you're really expending a lot of resources to find out they're all independent. They're all just basically at one level. So we developed the approach that said, okay, we'll deal with multiple cities at each level as we get that information. And so that's just a balance of resource allocation and how much it would actually cost to to do the complete filtering up front, or to do the filtering as you go through the process. So,
and then I guess that's good. And so then when that is complete, when the computer has done that, is there an output then that is a display of that ordering?
Yes, the matrix itself.
Okay, so the matrix itself. So I guess what I was thinking about possibly was some kind of oh, I see. Yeah, the way the matrix actually is just the way that the columns and the rows have organized themselves in that previous point. So you actually get them in the way that you've got the one that's the most north at the top of the page, and the one that's,
right.
Okay, exactly. Yes, of course, right. Okay, yeah.
And then if you want to have other types of graphs or other types of graphical displays of the information, then you could. It's very straightforward to take the graph, the matrix, because this matrix is in memory and in standard matrix form, right? So let's see.
Right.
Just pull up a spreadsheet here, and see if I can start Sage Math. Give me a second to do that. Then we'll take a look at the worksheets, because you can use Sage Math, or you can use Juniper or IPython notebooks to draw all these other mathematical forms or graphs or networks or whatever you'd like to see.
Yeah, I was wondering about that. Based on the matrix, is different graphical representations, because the way it's put on the grid, it has a certain linearity, which is actually masking I think it's masking some of the possible graphical relation. Does that make sense?
Right. So what we're looking at now is the human kind of. This is the interface for the human data acquisition.
Right.
And then the matrix form then is taken and can be used within the Sage formats. Let me bring this over here. It'll take a while for it to come up. And so all of this code and all this information, again, is available in the zip file on GitHub. And it is our first, again, as I said, it was our first cut at it. So let's go here and type notebook. And it takes it a little while to come up. And we have an error that says, let me see what error says. Twisted. Okay, that might be because maybe it wasn't all loaded yet, or nope, there's something different here on permissions. So I'm not going to be able to do that right now.
Okay, never mind. All right.
But yeah, the idea basically is the Sage notebook itself is there. You get a Sage account. I'm having a permissions problem here. Have to change directory. Okay, well, I'm not going to do that now. And but to go through that part, and let's see, that was the Sage Math. I think we may have had some indication of what was going on there with our, oh, I see. Yeah, worksheet. Let's look at this. See what this says. Right, okay. So there's the worksheet in non-form. So yeah, need to have a straight up one to do it. But the documents themselves, I think we have some. Let's see. We put some graphics in here. We did the binary relations. These are some of the things that we're working on. And there's this part. Well, this is all of the code that we've used so far in the document. But I thought we also had some graphs. Well, let's see. It's been a while, so it's kind of hard for me to remember exactly where those were. Obviously not in there. We'll maybe try the appendix. What was in the appendix? Okay, the appendix is just, again, the graphic transforms. Okay, so the Sage Math, I don't know if you're familiar with the Sage Math tool from the University of Washington, but it basically is what we've used to analyze that, and then you can use it because it has a very robust graphics, symbolic graphics languages, and it will generate all of the information that you need, whether you need it in matrix form or graphics form.
Okay. Yeah, I'm not, but that's good to know.
Yeah, it's just a different interface, between these two. All right. Well, I think that's kind of a general overview. Should get you going, along with.
All right. Thank you very much.
You're very welcome. It's good talking with you.
We'll give it a go. Thanks a lot.
Yeah. Take care. Bye-bye.